Hello, Legacy Sabers, Marsh here. So today we're going to talk about radical operations. You're going to want to have your stacked foldable, some form of writing utensil, and then a calculator to help you do some simple math. You may also want that perfect roots chart that we've been using throughout this unit. Our essential question today: how do you complete mathematical operations on radical expressions? So we are going to be on the final tab down here. So this radical operations tab is where you want to open to, please. So first, let's talk about what we already know. We know how to simplify a rational expression, right? Or radical expression. So simplifying the square root of 50, remember, we need to find perfect squares that go into 50. Biggest perfect square is 25. And we multiplied, right? So 25 times 2 would give me 50. We simplified square root of 25 to be 5. So my answer would be 5 times the square root of 2. Okay. Now, if we had a letter underneath, then we just do a little bit more simplifying. So we're going to break it into two pieces, like that. And then we had to simplify the third root of 54. So we had to find the biggest perfect square, biggest perfect cube to go into 54, which in our case would be 27. So this guy would have cube root of 27 and cube root of 2. Cube root of 27 is 3. And then cube root of x to the fourth. Remember we said, well, how many groups? This tells us how many people have to be in a group. And how many groups of 3 are in 4? There's one group of 3 with one left behind, right? So then we put the people on the inside and the people on the outside together. So we would have a 3, an x, cube root of 2x for our final answer there. What if you see a problem that requires you to multiply or divide? If you see that, things that we got to look for is we need to make sure the index is the same. That's the little number, remember, outside of the radical. If that's the case, we may create one radical sign and either multiply or divide that number. So let's practice. If I have the cube root of 4 times the cube root of 16, they have the same index. So I'm just going to be able to put it under one radical. So I can do the cube root of 4 times 16. 4 times 16 is 64. Cube root of 64. The cube root of 64 is 4. So my answer, 4. If I have two radicals divided by one another, then what I get to do is literally put it under one radical. So it'd be 80 over 5. So 80 divided by 5 is 16. So that is the fourth root of 16. Fourth root of 16 is 2. So if I have two little radicals, I can make it one big radical. And the reason for that is because technically that is 80 to the 1/4 power, right? Over 5 to the 1/4 power, which if I undid that fraction property or that exponent property, it would look something like this, which is right there. Okay, so that's why I'm allowed to accomplish that task. If I need to add or subtract, I have to have like radicals. So that means I have to have same index, and I also have to have the same radicand, number under the radical. So make a little note maybe, same index and same inside number. Then I'm just going to combine like terms, aka add the coefficients in the front. So let's try our first couple of problems here. Cube root of 5 plus the cube root of 40. I don't have like radicals yet because I do not have the same radicand. So I'm going to simplify the cube root of 40. Cube root of 8 is probably the biggest. And 8 times 5 is 40. Cube root of 8 I know is 2. So I'm going to rewrite what I have. I have the cube root of 5 plus 2 times the cube root of 5. Now notice I have a cube root of 5 and a cube root of 5. I now can add my coefficients together. This technically has a 1 there. We just didn't write it. So 1 cube root of 5 plus 2 cube roots of 5 is 3 times the cube root of 5. Because I'm just adding the coefficients in front. Same thing for subtraction. I need to simplify, so I'm going to find the biggest perfect cube that can go into 54, which I know is 27. And 27 times 2 will give me 54. Cube root of 27 is 3. So I'm going to rewrite that. Now I'm subtracting a 1 cube root of 2. So if I subtract those, I will get 2 cube root of 2. Kind of different, right? But ultimately, you are trying to get the same radical. If they would come out different, so like let's say I would have the 4th root of 2 right here, then I could not do what I just did, and the final answer would be 3 cube roots of 2 minus 4 roots of 2. Okay, let's try a couple more. So now here I got some x's inside. I need to multiply because they have the same index, right? So same index there. So I'm going to square root of 12x cubed because I'm just going to multiply my bases, which means I add my exponents. Now, just like what we would have done, I'm going to break that into 2 pieces. And I'm going to take care of each simplifying separately. So square root of 12, I know square root of 4 times the square root of 3. That's 2. 2 tells me how many people have to be in a group. There's 1 group of 2 in 3 and 1 left behind. And then I want to put my answer. So outside people are 2x. Inside people are 3x. Now on this one, I could make this one radical, right? But you know what? I'm seeing the cube root of 27 down there, and I think that simplifies on its own. So what I'm actually going to do before I break this into one big radical, I'm going to simplify each of those individually and see if maybe that will make it work a little better. So I got, oops, there you go, my pen decided not to be working. Cube root of 128 and cube root of x to the 7th. That I need to simplify. Cube root of 128, I believe there to be a 6, looking at 64, right? So cube root of 64 and a cube root of 2. Cube root of 64 is 4. And then groups of 3, there are 2 groups of 3. 1 left behind. So the numerator now looks like this. I have 4x squared cube root of 2x. Now let's look at the denominator. So now I'm going to simplify the denominator. Cube root of 27, cube root of x to the 6th. Cube root of 27, we know that's 3. Groups of 3, there are 2 groups of 3, nobody left behind. So I would get 3x squared there. And you know what? I can simplify now, right? Because I have an x squared over an x squared. Everything's multiplied. No killing kittens here. So I can cancel those out. My final answer, 4 cube root of 2x over 3. Just like that. Whew, another one. Now notice, let's take care of maybe simplifying first before we deal with this addition. That way, maybe I can actually have like radicals. So I'm going to take care of the square root of 8 and the square root of x cubed. Square root of 8, I know that's the square root of 4 times the square root of 2. That's 2 square roots of 2, right? Technically, little index of 2. Groups of 2 has to be available. That's one group of 2, one left behind, right, out of 3. So this, in its entirety, because don't forget, got that 3 hanging out, I have 6x times the square root of 2x. Let's simplify the square root of 18. Square root of x doesn't really do anything, right, though? Square root of 18, that would be the square root of 9 times the square root of 2. I get 3 square root of 2, and I just put the x back. But we got that 6x that's hanging out, so that is timesing right there. So technically, I am adding 18x square root of 2x. Notice, same radical business. That means I can actually add these together. So I'm going to add the 6 and the 18, and I'm going to get 24, and then write my radical stuff together. Notice that didn't double. I didn't multiply those. I'm just adding the coefficients together for my final answer. So here's what I'm going to ask you to do. Go ahead and pause the video. Try this problem on your own first. Okay, should have given you enough time. Let me do it in front of you now. So I got 4th root of 32, 4th root of x. That's 4th root of 16 times the 4th root of 2. That would be 2 4th roots of 2, and then x coming down from the top. Do the same thing for the top here. Ooh, 4th root. 81? Yeah. So 4th root of 81, 4th root of 2. That'd be 3 4th roots of 2x. I'm subtracting, so now double check. I have the same radical stuff, so I can subtract. I have -1 4th roots of 2x for my final answer. Whew, did they just keep getting bigger and bigger, people? So let's simplify each individual piece one at a time. Now, notice the x and y aren't going to simplify. But 4th root of 16, that's 2. So I know this is 2 times the 4th root of xy. 4th root of 81, that's just 3, right? Simplifying this one, 4th root of 625, 4th root of x, 4th root of y. 4th root of 625, that would be 5, right? Put my xy back. That's subtracting. And then 4th root of 256 is 4. Looking on my card here. Yep. So this is just a 4. Now, let's combine our like terms. I have 2 4th roots of xy minus 5 4th roots of xy, which means I have -3 4th roots of xy. And then I have a +3 and a +4. So I got +7. That could be written back and forth. So you could write 7 minus 3 times the 4th root of xy. Doesn't really matter. However you want to write that. Another one here. This one, notice, it is multiplying. It's 2 binomials. We have to FOIL. I know. How exciting, right? So 6 times 8, 48. 6 times -2 square root of 2. That'd be 6 square root of 2x. Excuse me. I think I said the wrong thing earlier. Minus 8 square root of 2x. And then plus, I'm going to multiply the insides, the radicands. I'm going to get 4x squared there. I can simplify these guys. This is -14 2x. because they have the same radicands, same radicals, right? Like radicals. This can simplify. I'll get 2. That's just an x, right? So add 2x. And unfortunately, even though it looks absolutely disgusting, these are all unlike terms, and I cannot simplify them any longer. So I have to keep it just like that. And the last couple here, just like when we talked imaginary numbers earlier in the year, we could not have an imaginary number in the denominator. Same thing happens when we're talking radicals. You're not allowed a radical in the denominator. Now, you guys have rationalized the denominator quite a bit in your time. However, you've probably never rationalized the denominator when you have a plus or a minus down there, just when there was just a radical, right? Square root of 6. You would have multiplied by the top and the bottom of the square root of 6. To take care of the denominator when it has a plus or the minus in it, you're going to do exactly what we did when we multiplied with imaginaries. And remember, we found the conjugate, right? We found the denominator, but with a sign change. So we're going to be technically multiplying by this on the top and the bottom, the square root of 6 minus the square root of 3. So we're going to have to do a lot of FOIL in here. So let's multiply the top there. We're going to get 2 square root of 6 minus 2 square root of 3 minus square root of 18 minus square root of 9. I'm just going to keep that the way it is for right now. Bottom, I'm going to get square root of 36 minus square root of 18 plus the square root of 18 minus the square root of 9. Notice that denominator simplifies. Those guys can cancel out. They're the exact same thing. Square root of 36 is 6. Square root of 9 is 3. So I have 6 minus 3. I have a 3 in the denominator. Looking at that numerator now, square root of 9, that's just 3. I can simplify the square root of 18. That is a square root of 9 and a square root of 2, which would give me a 3. So I'm going to rewrite what my numerator is here. 2 square root of 6 minus 2 square root of 3 minus 3 square root of 2 minus 3. Oh, gross. You know what? Not a single one of these square root business. Simplify. You can't combine any of them. They don't have like radicals. So my official answer to this problem is 2 square root of 6 minus 2 square root of 3 minus 3 square root of 2 minus 3 all over 3. Whoof. Bad answer, right? But that's as simplified as far as it goes. And the final problem. I'm going to let you pause. Go and pause here quick and see if you can get this answer before I start. All right, let's go for it. Oop, lost my pen here. Okay, I'm going to multiply these guys together. 18m cubed nq cubed minus 32m cubed nq cubed. Now, I am subtracting, so I need to have like radicals. Right now, I don't have like radicals, right? Because I have an 18 and a 32. The rest of my letters are 100% the same, but I need my numbers to be the same. So I'm going to simplify the square root of 18, and I'm also going to be simplifying the square root of 32. Square root of 18, I know would be 9 and 2. Square root of 9 is just 3. So I'm going to rewrite my problem here. I have 3 times 2 square root of 2m cubed nq cubed. Square root of 32 is square root of 16 times square root of 2. Square root of 16 is just 4. Now I'm just going to rewrite. There. Now notice, I have the exact same information on both of them. So now I can just subtract. 3 minus 4 is negative 1. 2m cubed nq cubed. Just like that. And that is the end of this video. I know operations with radicals are kind of crazy, and it takes a lot of time to understand and to work through these problems. They are, however, super important as you continue in your math career. So that's why we're going to spend a little bit more time making sure we understand these problems so that we can solve and simplify really, really difficult looking problems. I will see you later, Savers.